Good morning or afternoon, whichever it is. My name's Sandra Brooke. I'm a member of the research faculty here at Florida State University Coastal and Marine Lab. And thank you for taking an interest in marine science. And I just want to talk a little bit about me and about what you will be seeing today. So I started off in marine science, or I got here rather, by a rather circuitous route. I wanted to be a vet when I was younger, but I wasn't quite clever enough, so I didn't get into veterinary school. At that point, I really didn't know what I wanted to do except to go and explore interesting places and get out of rainy old England. And so I did a degree in biology. And then I did a master's degree, which enabled me to go and work in Costa Rica on the banana farms for 3 months. It was a degree in pest and disease control. So after I graduated from that, I went to work in the Cayman Islands and I learned to dive. After my time was up there, I decided I wanted to go into marine science. So I went and did a degree in Virginia. I've been collecting pieces of paper my whole life, and got a degree in marine science, which I followed with a PhD in oceanography down in Florida. And it was there that I discovered deep sea biology. I worked at an institution that had its own research vessels and owned the Johnson Sea Link submersible. And I was fortunate enough to do a lot of deep sea, really interesting deep sea projects, and my PhD was focused on deep sea corals. So that's what got me into there. After that, I went to Oregon and did a postdoc, carried on working on deep sea corals in Norway and Alaska, the Gulf of Mexico, southeastern US. And after my contract there was up, I took a job working for Florida State, managing the coral monitoring program in the Florida Keys. But state government and I didn't really get along too well, so I left there after a year, bounced all the way back to the Pacific Northwest and took a job with an NGO, which is a non-profit organization in Washington, in Seattle, and I was the director of coral conservation, which sounds really grand, but I was working on programs that tried to protect deep sea corals. And so I was there for 4 years, but my heart was really in research, and so I was again fortunate and came back to here, to the Marine Lab in 2013, and have been working on coral ecosystems mostly ever since. I started out in marine science by really wanting to dive, and doing the deep sea work doesn't entail an awful lot of scuba diving, and so it's really nice now to be back working in the shallow ecosystems. So I suppose what I wanted to say in all that sort of rambling is that even though you don't really know where you want to go and you don't follow a direct career path, if you keep at it, things come up and opportunities come up, and you kind of end up where you want to be in the end. So don't be put off if you have to take a bit of a detour. Sometimes things don't go as planned. So most research programs focus on one general area, but they usually sort of branch out into different aspects of that area. And this is driven by funding. Unfortunately, for the most part, we can't always work on exactly what we want to, so we have to expand a little. And opportunity. Sometimes things come up and interesting things branch off of your main study area. So these research programs sort of tend to mushroom a little bit. So my research focuses primarily on coral and sponge habitats, both in the deep sea and now in shallow water also. And within that, there are some general focus areas within that sort of main umbrella. One of the things I look at is habitat characterization, and what that means is surveying, mapping, and exploring habitats that are previously relatively unknown, describing the habitat types, describing the communities associated with them, and then trying to work out what it is about the habitat that supports the communities that we see. So rocky habitats support things like sessile benthic fauna, sandy habitats support lots of worms and things like that. So it's a bit simplistic, but that's kind of what we do. We try and correlate habitat, environmental parameters, and the animals that we see there to try and work out why they're living there and how they make a living. The other aspect of what I do is looking at the basic biology of these animals. And in that I've focused on reproductive biology and physiology of usually corals, sometimes other animals too, but usually corals. We use a process called histology, where we sample the corals, we remove their skeletons, and we send them through this process, which my student Austin will explain to you in greater detail when I shut up and you get to look at the lab. And we take them through this process, and that allows us to look in detail at their tissues, and we can tell what their reproductive stage is, whether they're almost ready to spawn or whether they're just starting their cycle. And from this we can work out a lot about how the animals make a living, how they reproduce, and where their larvae might end up, what their larvae are like, and all sorts of things like this. We can understand their life history. The other thing I do is work on physiology, and by that I mean growth rates of corals, what their environmental tolerances are, what kind of temperature range they can survive under, what happens when it gets too warm or too cold. All of these things are really important in helping us determine where these animals might live, and now what might happen in the face of climate change. What happens when it gets warmer? What happens when the oceans get more acidic, and so forth. So what you will see today is a series of things that we've laid out for you. One of them, the first one that you'll look at, first exhibit you'll look at, is a series of information plates that tells you a little bit about deep sea corals, where they live, what they are, how old they are, and so forth. And there are some samples of deep sea corals that we've collected over the years from different places that will be in the middle of the table that you can handle and ask questions about. And then you'll see a video that was put together by NOAA in an area called the Middle Atlantic Canyons. And this is an area where my latest project is located. But NOAA makes a lot prettier videos than our work videos, so we're going to show you this one instead of our rather boring work videos. So Austin can talk you through it, but basically it was taken by a remotely operated vehicle, which is a platform that we use in the deep sea. It's attached to the vessel, so we get real-time video and real-time data on what's going on down there. And it can also collect samples, which we really need to do the biology that we do. So he will talk you through this video. There's some beautiful pictures and images of corals and some of the other creatures that we see associated with these corals. Because that's the thing about these animals, is they support, just like in the shallows, they support a very dense and abundant and diverse community of other animals. This is their real value, is in they provide habitat for other animals. So you'll see the video. And then we'll talk about the histology that I mentioned, and Austin will walk you through the process of how we do that. It's a rather lengthy and involved and sometimes rather boring process, to be honest. And then we'll talk about, or he'll talk about, what we do with the coral skeletons and how we work out how old some of these corals are. I must say that some of the work that we do is really interesting, it's really exciting. Going to sea is a lot of fun if you don't get horribly seasick, which I do, unfortunately. But that's the fun part. But the fun part is a very small part of the year. We might go out to sea for 2 or 3 months. If we're scuba diving, of course, it's a little bit easier to get out there more often. But a lot of research is actually in the lab processing data, which can be tedious. Some of it's interesting, some of it is really tedious. It's a lot of hard work. So even though there are aspects of this career that are absolutely fascinating and wonderful, there's also the other side of it. You've got to be prepared to work really, really hard. So thank you for your interest in marine science, and thank you for your interest in the lab, and I hope you find it fun.